All right. So a system of equations is just two or more equations. So we are looking at two or more equations at the same time. In terms of the solution, those are the ordered pairs that make both of them true. So we can have ordered pairs. I'm going to say it could be more than one because we did some nonlinear ones at the very end. So if it's just lines, it's a single ordered pair. If they're not lines, we could have more than one. We know it's no solution if they don't meet. In terms of lines, what kinds of lines would never meet? Parallel. Or we could have infinite solutions. If they are the same line. All right, so I'm going to do one of these with you, and then we're going to talk what other strategies we could use. So if I look at problem number 4, if I'm going to graph a line, what form do we need it to be in? Okay, so if I take that first one, the 2x plus y equals 1. If I need it in y equals mx plus b form, what do we have to do? So y is negative 2x plus 1. How do you graph that?
1 on the y-axis,
Mm-hmm.
and then left.
Okay, so we put a point at 1 on the y-axis. So then we could go down 2, right 1. Or the other option is up 2 and left 1. And then you have your ruler to draw a straight line. And I do a bunch of points because I'm not good at drawing straight lines up here. Okay. Then we need our second one. So that was x minus 2y equals 18. So if I get that in y equals mx plus b form, subtract our x. So negative 2y equals negative x plus 18. Then what would you do? Divide by negative 2, everything. So y equals negative, or positive, negative divided by negative, 1 half x. It's minus 9, yep. Okay, so that one would start at negative 9. Slope positive 1 half, so up 1 over 2. Okay, and what are we looking for on this graph? Where they meet. So that point is 4, negative 7. Okay, now EOC might ask you to graph it. There is a graphing tool. They might ask you to do that. If you want to check yourself, what could we do? Okay, if I go to Desmos and I type in, you can even go with your original problems. 2x plus y equals 1, x minus 2y equals 18. Then if I look, the point where they meet is 4, negative 7. And you can use that to kind of double check that your graphs are in the right spot. Okay, even if you had to use the graphing tool and draw a graph on the EOC, you could check it doing this and make sure your graph looked the same. Is that okay with everybody? Let's go to problem number 8. So we talked about different options for solving these. We can do the graph. We also did substitution and elimination. Remember, elimination, the goal was that when we added these equations, something would cancel out. And they cancel if their coefficients are the same number but opposite signs. So if I want to cancel, pick a letter, X or Y? Y. What would I have to do first? Okay, so there's different options. If you want to do substitution, we could solve for it. If you want to cancel your x's, we need to make, if this one's a positive 2, that one would have to get multiplied by a negative 2. This is a negative 5y, so I need this to be a positive 5. So if I multiply by 5, that's everything. We're going to take all of them. So it's 5x plus 5y equals 20. And 2x minus 5y equals 15. When I add these equations together, we get 7x, the y's cancel, equals 35. If we divide by 7, then x equals 5. Once you have x, how do you get y? So I go back to the original. X plus y equals 5. So if x is 5 plus y equals 4, subtract our 5, so y is negative 1. How do we write our final answer? Ordered pair. All right, how would you check yourself? Plug them in. You can put these points into both equations. They should work. What other resource could we use? Desmos. Could you graph these original lines and see if they met at that point? So lots of options for checking ourselves there.
I'm so confused on how you even got the 5 and multiplied by.
Okay. So we just kind of picked a variable. Which one do you want to get rid of? And they said y. So in order to get rid of them, one has to be positive and one has to be negative, which they are, but they have to be the same number. So the bottom one was a 5y. So we just said, what do I need to multiply that one by? So we took it times the 5.
So that was x and b two.
Let's try another one of those. Let's go to number 12. All right. This one's set up a little bit differently. We could do the same thing if we first just subtracted over the 5x. Or, what other strategy could we use here? What might be easy? Is elimination easy right here? Not really, but we could do substitution, couldn't we? I'm telling you, y is 5x minus 27. So you could go to the other equation and replace the y with the 5x minus 27. So we get 2x plus 15x minus 81 equals 4. 2x plus 15x, 17x minus 81 equals 4. Add our 81 to the other side. So 17x equals 85. Divide by 17, and x is 5. And once you have x, how can you get y? Plug it in. So either equation, I'll just go with the second one. Y is 5 times cx minus 27. So 5 times 5 is 25 minus 27. So we get -2. So my answer is the ordered pair 5, -2. And if you use Desmos to graph them, they meet at that point. So we know we're correct. Okay, how are we doing on this so far?
But there's some of you that have 2 Y's and 2 X's.
So that's one where I would probably do elimination. Like we did the first one where you multiply by something so that when you add them together, they cancel out. So like, you know, when they're set up like, this one I'd probably say stupid because it's next. But this one where they're lined up, I would multiply by something. So it's not multiply by something. What can we come up with this numbers? If something was 4 times 5 is 100. So we can take the first one times 5 to get a 20. And the second one times a 4 to get a 20. So we can we'll do it somewhere here. And these will so we'll try that one. Let's look at 14. And this we'll practice another elimination problem with this. So the Boy Scouts are selling 2 types of popcorn as part of a fundraiser, butter and caramel. Butter popcorn sells for $5 per bag and caramel sells for $6.50 per bag. So far, Alec has sold 40 total bags and raised $221. Find the number of bags he has sold for each type. So I'm trying to find the number for each type. So those are my variables. So X could be the number of butter. Y could be the number of caramel. Okay, so far so good? Now, if he has sold 40 bags, what would my equation be? What did you say? X plus Y equals 40. All right, then we know the price of popcorn is $5 if it's butter flavored. So to get the cost for all of those, we would just do 5x plus 650y equals 221. Okay. Now we have to do elimination. So let's say I want to eliminate my x's. They have to be the same number but opposite signs. So what could you do? Take the first one times -5. So -5x minus 5y equals -200. And we didn't change the second one. When we add those together, the x's drop. -5 plus 6.5 is 1.5y. -200 plus 221 is 21. Divide by 1.5, and what do you get? 14. Okay, so now we have y, we need x, so we can go back. X plus the y, which was 14, equals 40. So x is 26. So we need 26 bags of of butter and 14 bags of caramel. I want to do 2 more problems. questions so far? Okay, let's look at 18. You guys remember how to do inequalities? Okay, let's start with if it were an equal. How would you graph y equals negative 3x minus 1? Start at negative 1. Slope is? Okay. Now, if we don't have an equal to, what does that do to our line? A dashed line. All right. So we're working on strategies right now. If you don't know how to graph something, what would you probably do? Type it into Desmos. Let's look at what Desmos does. So we have y is greater than negative 3x minus 1. It has that dashed line, and then what did it do? Shaded. And we talked when we did this different ways to know where to shade. We usually kind of pick test points, but for the purpose of this, use Desmos. If you don't know where to shade, type it in and see. So our solution is just any ordered pair in that shaded part. And we see Desmos even shows us that it's a dashed line. So all of the points over here would work. Last one I want to do, let's look at 24. So what would I have to do if I'm going to graph those by hand? Yep, subtract that 4x over. So y is greater than or equal to negative 4x plus 4. We start at 4. Slope is negative 4, so down 4, right 1. Or you could go up 4 and left 1. Would this one be solid or dashed? Why? Okay. If you remember, greater than is going to go to the right, but if you forgot, we can always plug in our line. We were graphing 4x plus y. If you look, you do have a toolbar with all these inequalities, so you can do greater than or equal to 4. And it shows me. I'm shading to the side. But that's not my final answer, because we have a second equation as well. So let's look at that second one. What would we have to do to graph it? So we have negative 2y is less than negative 3x plus 14. How do we get rid of the negative 2? If you divide by a negative, what happens to the inequality? It flips. So y is greater than 3 over 2x minus 7. Start at negative 7. Up 3 over 2. Solid or dashed? Dashed, because it doesn't have an equal to. Okay, greater than is above, but if you're not sure, look at Desmos. My equation was 3x minus 2y is less than 14. And look what happens. What's the actual solution on here? It's that overlap. Okay, so when we did those, we lightly shaded in both of the individual ones, and then I had you do something like darken in that overlap area. So anything in this section works for both of those points. All right. Any questions for me? So your problems, and remember you can do more for extra credit. 3, 5, 7, 11, 15, 19, 21, 23.